Now let us discuss about separation process of components of air. Okay, so first of all, the thing that you have to know is this one: how can we obtain different gases from air? Now see the table. Here it is given that nitrogen 78.1%. That means in air, how much nitrogen is present? Out of 100%, 78.1% is nitrogen. That means the maximum amount of gas which is present in air is the nitrogen. Okay, then it is oxygen. See the percentage air in by volume, it is 20.9%. So 78.1 plus 20.9, how much is that? This is 99, right? 78 and yeah, it is 99. All right, so see, 99% is nitrogen and oxygen only together, it is forming 99%. So how much more is left? Only 1%. Now out of this 1%, argon is present 0.9%. So that means how much percentage remain? 0.1%. So that 0.1% is the other gases like carbon dioxide and all. Okay, so that means in air the maximum composition, maximum amount of gas which is present is nitrogen, then it is oxygen, then it is argon, and then the other gases. All right, now see, focus at their boiling point. Nitrogen is minus 196, argon is minus 186, oxygen is minus 183. Now out of these three, which one is having least boiling point? C, that is nitrogen. The reason is that though the number 196 is more, but actually it is less because it is minus in negative scale, minus scale. You know this one. So out of these three temperature, that is minus 183, 186 and 196, which one is the least? Nitrogen, that is minus 196 is the least. So suppose in some cases, if you have all these three gases and if you are supplying heat, which one will undergo boiling first? That is nitrogen, because nitrogen, its boiling point is least out of these three. So first nitrogen will boil, then which one will boil? Then it is which one after nitrogen? If you see the number line, what it should be? It is argon, right? After nitrogen it is argon, and then it is oxygen. So oxygen will boil at the last. Okay, now let us look at the apparatus. This is the procedure. So I'll describe one by one part of it. So first one, it starts with filter. What is the purpose of this filter? So the purpose of this filter is to filter the air, because in air, apart from gases, some other particles are also there, like uh, dust particles. Okay, so to purify air, to remove those dust particles, this filter is used. And once the air passes through the filter, now the air is dust free. So this air, it is taken in this chamber. This chamber, first chamber is this one. Okay, so here you can see two pistons are there, towards right and towards left. Two piston, what they do, they compress the air present. All right, they compress this air, and as a result air gets, it remains in a very high pressure. So due to this high pressure, the temperature of air increases. So air, now it becomes hot air. So this hot air, through this pipe, it is sent to the next chamber, this one. Okay, in this chamber you can see that this spiral uh, tube is there, and through the bottom of this tube, freezing cold water is taken inside, and from the other side water is taken outside. So what is the purpose of this water? Freezing cold water, very chilled water. So what is the purpose of it? See, the hot air which is coming to this chamber, this water, this freezing cold water, it is actually reducing the temperature of hot air. Okay, and once the temperature of hot air is reduced, now it will be cold compressed air. This cold compressed air, it is taken to the next chamber, this one, this blue color uh, part, right? It is taken to the next chamber, and what is the next chamber? That is a separator. Now the air is cold and compressed. Under this condition, what will happen? The carbon dioxide which is present in that mixture, it will become dry ice, because we know that carbon dioxide, it undergoes direct deposition. That means from gas directly it gets converted to solid, and solid carbon dioxide is what? It is dry ice. So since it is solid, it can easily be separated through this path. You can see here it is written carbon dioxide out as dry ice. Okay, this part. So from this this solid carbon dioxide will come out. So once this solid carbon dioxide comes out, now what are the other significant gases present in the separator? We have oxygen, argon and nitrogen. Alright, then through this liquid air, through this expansion jet, this liquid air is pushed in the next chamber, that is the fractional distillation column. So in this fractional distillation column, all the gases will be heated up, and just now I told you that out of argon, nitrogen and oxygen, nitrogen is having the least boiling point. That means it will first boil. First, which one will boil? That is nitrogen. And once the gas is undergoing it is boiling, its density becomes less, it becomes lighter. So once it becomes lighter, it will go up. So you can see that for the nitrogen, outlet is the upper one. Two outlets are there, nitrogen out and argon out. Nitrogen is the upper one, because nitrogen will undergo boiling first and its density will reduce, so it will go up. So when it goes up, through this outlet nitrogen can be collected. Okay, and I also told you that after nitrogen, which gas will undergo boiling? That is argon, because its boiling point is just next to nitrogen, right? So after argon boils, then just below nitrogen we will get argon. So this argon will be collected from this outlet, and remaining what gas will be there? That is oxygen. And this oxygen, as the boiling point of out of these three, oxygen is having the maximum boiling point, so it will take time to undergo vaporization, and by that time, before it undergoes any boiling and all, it can be collected from the bottom part in this chamber, and the oxygen is still in liquid form, because its boiling point is more. It has not undergone any vaporization process, so directly the liquid oxygen can be collected in this chamber or in this vessel. Okay, so I think now it is clear. So that is how we can separate the different parts of air. So for today, this much. Then we will discuss the next topic, that is this one, activity 2.9. Thank you.